All right, this is section 8.1. We're going to talk about Laplace transform. Right? So transform. So if you have any function f of t, so our goal is to change this one into very simple form, like a of f of s. So with a different variable s, right? We want to change into that form, and then we're going to solve it, whatever you want to solve, whatever you want to do it, you do it there. And then you're going to apply inverse Laplace. Inverse Laplace, you're going to apply that one there and get back to the original f of t, like a solution of f of t. Okay, that's the goal here. So in the next section 8.2, we're gonna use this Laplace transform to figure out how to solve differential equation. Okay, so this is very common, like Laplace. This is very famous French mathematician. All right. So this is we use in control theory, right? Like if something is like if you want to put it in some kind of control environment, we use this Laplace transform is very useful there. Okay, so but let's see what is this Laplace transform looks like, right? So if you look at this, this is like I don't know, this L, or you can just put this L, Laplace transform of f of t, any function f of t. If I apply this one, means, what does this mean? This means you're gonna do the antiderivative integral from 0 to infinity. When you multiply with this e to the power negative st. T is a variable, s is a constant, right? So here, so you're gonna apply this one, you're gonna multiply with this one to your f of t, and you find this integral, like indeterminate form, right? Integral, and then you're gonna change into with a limit. We calculate this integral and find out whatever you find out, that is your f of s. Okay, that is in the form of f of s, like a function with s is the variable there. Okay, so let's look at the example. I think when you start looking at this example, it'll be much easier. Okay, so let's say before we even do that, let's review this integral. When it's 0 to infinity, what do? You took the limit, you took the integral, so you're going to go 0 to b, right? So b is infinity because you want to make it in a determinant form, right? And then take the integral. Integral is like a 1 over c is a constant there. C is a constant, okay? And then you take the limit, like a b first, and then you put a 0, that makes them just the 1. And then when b goes to infinity, and then you're going to figure out the value, right? So, but it depends upon this c, right? C value. If the c is a negative number, if the c is a negative, what happened? If c is a negative here, what happened? If b goes to infinity, what happened? This e to the power bc is going to goes to 0, right? Because it's like e to the power negative infinity, like that, right? And that goes to, that is the same as 0, right? And in that case, you can figure out what is the integral, right? Antiderivative. So it's a finite number. So that means we are able to control this. We are able to figure out what is the integral. But if c is bigger than 0, what happened? So this quantity goes to infinity. E to the power bc goes to infinity when b goes to infinity. In that case, I mean, we cannot work on that kind of problem, right? So as long as when I multiply, as long as we have this finite number, we're able to find the Laplace transform. That's the idea here, okay? But like, so let's look at the first example. What if your f of t is just the 1 constant? Like a 1 can be any number, but like a constant 1. So what you're going to do is Laplace of 1 means, this is our definition, right? E to the power negative st, and then this is your f of t, right? Just like here. Let me go back here and look at that. If f of t is over here, and that means e to the power negative st, you multiply with that always like that. And f of t is your function, okay? So in this case, f of t is just a 1. I'll just put a 1 there, and then dt. And now the 1 doesn't do anything. You take the antiderivative. Antiderivative looks like this, right? Your s is a constant. And then 0 to b, and then you plug in that b there. And then when you plug in there b, and when b goes to infinity, what happened? This is going to be just the 1 over s, because that's just the 1, and that goes to infinity, right? That goes to 0. And that's a negative, negative, positive, and that's just the 1 over s. So what does that mean? Laplace of 5 is what now? That means it's just a 5, 1 over s, which is 5 over s. Any constant is just a 5 over s. Laplace of 10, what is that? That's just 10 over s. So if I apply the Laplace on any constant, just a constant over s, because I just, now this is the function of s, like that, right? I change in that form. So here we're going to do that. Let's look at another example. What about EAT? So EAT, f of t is your EAT, okay? Exponential function. A is a constant there, okay? Again, what's the definition? 0 to infinity, e to the power negative st, you multiply with that to your f of t. This is your f of t, right? You multiply it. When you multiply it, it looks like that. Now we're going to do the antiderivative. So when I do the antiderivative, that's a constant. Now think about this. The whole thing is a constant because here the variable is t, right? Variable is t. So 1 over a minus s, right? And then you just look like that. And now replace b. Now you put the limit there. So it's look like that. And then this last part is 0, e to the power 0 here, which is 1. Now if you look at here, when b goes to, it depends on your a. If a is bigger than s, what happened? A minus s is always bigger. That's a positive number. So that means this whole thing goes to infinity. So that means this goes to infinity, means diverges. So you really cannot do anything there, okay? But if a is less than s, that means a minus s is negative number. Make sense? It's a negative number. That means this goes to 0. When it goes to 0, then when b goes to infinity, this whole quantity goes to 0. Okay, so that means when you look at this one, this whole thing in this, if you look at here, this only left is 1 over a minus s, but like there's a negative, so that makes it 1 over s minus a. So what does that mean? So if you have a Laplace of e to the power at, if I apply the Laplace transform there, it's exactly same as 1 over s minus a. Now that means if you look at here in the star here, Laplace of e to the power over here, if you do Laplace of e to the power negative at, that's exactly same as 1 over s plus a. So you don't have to memorize this one, but there's a table, you can look at it and then figure out. So there's a table here, okay? So I'm gonna just go down here table before I do this next problem. So let me just go here and just show you here, okay? Again, if I apply the Laplace of 1, you're gonna get 1 over s. Laplace of t is just a t, is your f of t is you're just a t. Apply, you're gonna get 1 over s squared. If Laplace of t squared, that's this one. So you have to know these things, all right? So you have to make a table on this one before you come to exam, right? So these are important one, and these are the important one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You have to know this. 10, all right? Yes, you need to do 11. The hyperbolic function, we haven't done it, so you don't have to worry about this hyperbole one. And then do this one and this one, right? These are the things you have to know, okay? So if you see e to the power negative at cosine bt, what is the Laplace transform of this one. That's a s plus a. A comes from here, and a b is over here, right? A plus s plus a squared plus b squared, like that, goes like that. All right, so I have one example. I'm going to go to the next video. I'm going to show you this, number 4, okay?